Hi, this is Peter, and this video is going to be to show you what I've been working on with respect to the landing gear nose steering and the braking system and also the flight controls. I figured it would be much easier to do a video and show you all the different things rather than putting up a couple of pictures and trying to explain it all and then kind of leaving a bunch of questions unanswered. So let me start off just talking about the rudder system for steering, and then I'll go into braking, and then I'll show you the flight controls. So with the Raptor, what I've actually designed in here is the rudder pedals are adjustable, and as you can see here, there's this brace that comes from the firewall here and comes down to and meets with under the dash, and I've obviously got the dash hidden right now, but you can see here there's 3 rods that this fixture mounts on here, and it slides back and forwards, and obviously that's how you adjust the position of the rudder pedals. And there's a 10-inch movement there, so you'll, with a combination of being able to move the seats back and forth and moving the rudder pedals back and forth, you know, whether you're 5 foot tall or you're 6 foot or 6'7" or 7 foot tall, you're going to be able to make it comfortable for you, not feel like you're trying to reach or you're squashed or whatever. So it's really going to be a good setup. And of course, the biggest problem when you design adjustable rudder pedals is how do you hook them up, because they're going to have to move, and you don't want to have a mechanical linkage because that creates a problem, because the geometry changes, and also with cables, the same type of thing. The cables will change, and so you end up, you know, having not a very good system. So I decided that if the brakes are hydraulic, then why shouldn't the steering be hydraulic as well? So if you actually look here, I'll explain how it works. So I'm just on one of the pedals, so on the left side here. So when you push on the rudder pedals here, it moves this arm back and forwards, and that moves this piston in and out. Okay, and it's just a very simple system here. So when that piston moves in, so let's just say you push on the right rudder pedal there, so that pulls this forward here, this arm rotates clockwise, it pushes this piston in, and then the hydraulic fluid in that line comes over here and pushes this corresponding piston out, and that in turn rotates this mechanism here, and you'll see in a minute that's connected underneath to the nose wheel steering, and at the same time pushing that piston out moves this other one in, which forces all the fluid out of that, and it goes down this line over to the left pedals and will actually push this one out, which has the effect of basically moving the rudder pedals in conjunction with the other side. So they both work independently, but the beauty of the system is that you can slide your rudder pedals back and forward, adjust them independently of each other, and not have to worry about any geometry changing that affects how they work. It's purely a hydraulic system, so it's really neat and tidy. And underneath here, I'll actually just change the visibility on this, or the transparency. So as you can see, underneath there is the gear, or the nose gear. So this particular rod here will pivot, and that's basically attached down there to the nose wheel. It goes through this main rod, which doesn't, but then it's fully attached to this one here, so that whole thing will pivot. And how that all works, when the landing gear retracts, or when it actually goes down, it meets up with this sort of thing here. So I can't really retract the gear right now, but as you can see, this gear will rotate around this point here, and these 2 little V things will disengage when you put the gear up, and when the gear comes down they re-engage, and that attaches the steering system there. And there's a lot going on in here that I'll talk about in a minute, but as you can see, that's how the rudder system works right now, and that's for the nose wheel steering. But and I'll show you again in a minute, but the rudder are actually hooked up to that as well. Well, actually, let me just talk about it right now. So here's this crazy looking contraption that looks something like out of Star Wars, but let me explain how it all works. So let's just take the example of you're pushing on your left rudder and wanting to turn left. Actually no, let's just do right rudder and wanting to turn right. Okay, so when you push on the right rudder, you need the nose wheel to turn to the right. Okay, so what ends up happening here is when you push on the right rudder, this piston here gets extended, which rotates this in a clockwise motion, which again is attached to this rod here, and that rotates in a clockwise motion. And then this next sort of piece or fixture or whatever you want to call it, that rotates as well in a clockwise motion, and that is attached to the nose gear via the V here, the mating V between it and the nose gear main shaft. And so that whole fixture turns to the right up to 40 degrees, and that's how you turn the aircraft when you're on the ground. Okay, so now how does it work with the rudders? The way that it's being designed here is that this fixture over here, or this connector point here on the left side, actually hooks up to the right rudder, so they're sort of sort of crossed as they go back through, down through the keel and up back over the main tank in the back there, and then of course they switch over onto the opposite wing. So what ends up happening is here, when you push on the right rudder, this rotates clockwise, that rotates clockwise, and as you can see down here, this point here is already pushed hard up against this thing here, and so when you push right, this thing will rotate right. And as you can see here, there's 4 different things here. The top one here is for the right rudder, even though it's on the left side of the aircraft, and then this bottom one here is for the left rudder, even though it's on the right side of the aircraft, and these other 2 I'll explain in a minute, but those are for the drag brake actuator. And all 4 of these will be riding on a regular sealed bearing there, so they could rotate freely around that center shaft there. So you've pushed on the right rudder, you're rotating this thing clockwise, and that in turn is pushing here, this interface between these 2 pieces, and it will move this thing through an arc of 40 degrees, and the actual movement here is a 2-inch movement from here to where it ends up over here, and the rudder connector rod is connected to that. So by pushing on that, you're pulling on the rudder connector rod, and then that goes back all the way out through down through the wing spar and right to where the rudder, where it turns that right rudder and deflects it to 40 degrees. So actually the rudders deflect 40 degrees, and so does the steering. So you should actually has really good rudder authority, being able to push it 40 degrees. So that's kind of how that works. And when of course you relax your pedals back to center again, that will just come back. Now that whole time when you were pushing on the right rudder, nothing was happening on this other arm over here. Nothing happened on that, because that can't go back any further than that, because that's the stop point for the rudders. In fact, there'll be springs holding these, so they will always return back to this center position here, or the non-deflected position if you're not using them. So and that whole time this fixture here had rotated away from this thing here, so it didn't have any interaction on it, so that rudder didn't get actuated. And of course if you push on the left rudder, this thing rotates anti-clockwise, and then that thing will get pushed that way, which will pull on the left rudder arm actuator, which will engage the left rudder. So they work kind of independently, but they're sort of hooked up to the steering mechanism. And for the reason why I've got this other thing here, this is for this speed brake, because I wanted to be able to also have a speed brake for the system that was operated by a push button on your stick, on your side stick. So there'll be a single little momentary, you have to hold it in to keep it actuated, button on the side stick, and that will operate an electric motor which will push this cylinder out here, hydraulically push this cylinder out here, and when this particular arm down here pivots around this point, and it's fixed in under the keel there, and so when that arm goes out, it pushes this whole arm fixture here, and it rotates around that bottom point, and so this point here will move to about here, and in doing that it will push this arm here and the corresponding one on the other side. They'll both get pushed forward, and as you can see, if you kind of look down through here, that's part of this arm here, and when it pushes forward, it can't do anything but push the rudder arm forward as well. And again, it's independent of where the steering position is. If the steering's in the center, this will just push forward, and both rudder arms will come forward because they're sort of pushed up against there. You can kind of see how that one sort of interacts with the other, and it's the same on the other side. And this one's kind of more obvious because you just got like a pillar there that's resting against that, so one just pushes the other. So you'll be able to push that button and both rudders will be actuated, and you let go and they'll just, because it's spring loaded, they'll just come back, and so the rudders will come back in. So that's kind of a nice system. It looks a little bit complicated, but if you think about it, it's actually very simple, and very little that can go wrong and very little that can wear out on it. So yeah, that kind of explains how that whole system works. And like I said, these will all be 4 different sealed bearings in there for each of those, so they can rotate independently. And then this arm here is a brace that literally braces from one side of the inside of the keel to the other. So you've got, you know, a point up here where this bolts to the top of the keel to hold that the shaft, so it, you know, it's not going to move around or whatever. And then this brace here is on the side of the keel to hold the whole mechanism so it won't move around. So anyway, that's kind of good. And then this will all just be CNC machined out of billet aluminum, so it should be fairly lightweight but still strong enough to do what we want it to do. Then the braking system, as you can see, if I go into that, you'll see behind each of these rudder arms here, rudder pedal arms, you have the brake cylinder, brake master cylinder, and the ones on the left side are connected over to the ones on the right side, and then they go and connect back. And we're going to be using the Behringer system, and once they connect back from the passenger side, they connect into this system here, which is their anti-lock braking system, and that provides just a regulated amount of pressure so you don't lock the brakes up. And then the system from there comes out here and goes into this little control, and that's for your park brake. And so there'll be a lever here that hooks up to your park brake system, so when you want to lock the brakes. And then out of these 2 things here will go to your left main brake and your left main brake and your right main brake. So that's kind of the braking system all sorted out there, nice and neat and tidy, and again be anti-lock, which is kind of nice. Okay, so let me talk now about the flight controls, and I'll start out with talking about the Aileron Control. So I've obviously got the dash hidden here, so you can't really see that, but as you've seen in previous pictures, the control stick, and this is the one on the left side, comes out the bottom left hand corner of the dash here. And so for working the ailerons, it's obviously just going to be rotating it to the left and the right, and right now it's configured for an 80-degree total throw, so 40 degrees to left and 40 degrees to the right. And as you can see there, it's kind of, the center position is kind of on an angle, so it's not like straight up and down, obviously, because you'll be hitting the outside of the inside of the door trim if it was straight up and down. So here this will move from this position over to about here, and that will be full left aileron, and then it'll move down to almost horizontal, actually close to horizontal, for full right aileron. And what that actually does behind the dash here is it moves this particular fixture here, which in turn that's completely adjoined to this arm here, and that moves this rod, and then you have this larger rod here which goes down into this thing. And the reason why this is down in here like this is because there's going to be a bearing in here which is going to be sealed for the pressurization, and this is the cleanest way to ensure pressurization of the cabin without having to do a bellows system or anything, or cables or anything like that. So it's a nice, neat way of making sure that the system or the cabin stays pressurized and still having all the geometry of the controls work correctly. So as you can see here, when you, let's say if you move the control stick to the left here, that's going to rotate it this way, anti-clockwise, which will in turn move this arm closer to the center of the aircraft here, which will move this arm across here and then back down here. That arm ends up being connected to here, and so because it's moving across this way to the right, this will rotate here, this thing here will rotate clockwise, pull this arm down, which ends up pulling this arm here back for the ailerons, and we go all the way out here, it's pulling this one back here. I'll rotate around so you can kind of see what's going on here. So that pulls this back here, which in turn pulls this arm back here, which in this part here you obviously can't see, but that is inside the aileron, and that will pull on the aileron and it'll rotate around the hinge, which is here, and so it has the effect of putting the aileron down, and so that's how you make your left hand turn. okay, because that aileron will come down, make the wing will go up here, and you'll make your left-hand turn. So that's kind of how that works there. And let me now explain how the elevator part works. So the elevator, obviously you're pulling on your stick, moving it in and out, and by default you have a 15 degrees pitch down. So in other words, the elevator comes up, so it can come up 15 degrees and it can go down 30 degrees, so you have more authority when you're putting it down to get your nose to come up, because you don't really need to have a lot of nose down authority on the elevator. So like I said, 15 degrees the elevator comes up, and 30 degrees it goes down. So how that translates to the actual control stick here, this is the center position here, you'll be able to push it in about 1.7 inches, and it'll come out about 3.4 inches, so the total travel is about 5 inches there. So it's a little bit less than probably what you're used to in some other aircraft, but in terms of being comfortable and not having to move it so far, like maybe a Cessna 182 where it can really come out a long way, you don't have to move it quite so far. So the controls should be light because of the horns that we have on the elevator to ease the control pressures. So it should be kind of nice, but still not feeling like it's overly sensitive. So when you move that the control stick out and back in again, this little pin here is basically locked into that center thing, so it can slide back and forwards and not sort of interfere. But that pin there is really to make sure that the ailerons work, so it sort of slides back and forwards and allows it, so when you rotate it left and right for your aileron control, that this actually moves. But this whole arm in here moves in here, and this is attached, that's fully attached right to the stick all the way back to there. So when you pull back on that, it pulls back on this arm, and let me see if I can get a good angle on it here for you. Let's go back here. Okay, so it pulls back on this arm, which rotates this rod, and you'll see that this rod is interconnected with a sort of a duplicate rod. In fact, I just haven't extended it here, but they're both the same length. Well, they're both full length. And again, we're still inside the cabin, the pressurized cabin here, where these rods are connected. As you can see, the second rod that gets rotated when you pull back, and here's where it goes through the firewall, or actually I should say the forward bulkhead, kind of like a pressure wall. There'll be a bearing around here again which seals that, so you don't lose any pressure through there. And once it goes through there, you can see it's basically going up into the foreplane there, and I'll just hide this here so you can see what's going on here. So again, that's rotating, and so you see there's 3 different arms here. I'll just pick this one. So again, when you pull back on that, it's pulling that arm back, which in turn ends up pulling this arm back, and you see that there's a rod here which goes through the back side here of the main part of the foreplane, and I'll just hide the top of the elevator here. And you see this is where it connects to the actual elevator itself, and when you push back on that, this moves, or sorry, when you're pulling back on that, it's moving this whole arm backwards this way, and basically pushing on the elevator to move it back this way. And you see in those previous images I had on the website with this roller hinge system, the whole elevator system will roll back on these hinges, and because these arms are curved, it will rotate the elevator to give you the effect of 30 degrees, a 30 degrees pitch down. And likewise, when you push forward on the stick, all this thing rotates forward, and the elevator comes up 15 degrees. And there's 3 of these control rods that hook up here to make sure that the whole system rotates in conjunction. It doesn't sort of get pulled or get sort of locked sideways or whatever. It's going to be a nice smooth mechanism, so you don't have to worry about it getting sort of crossed up or anything like that. And those arms that are there, you'll see that they basically just attach to the back of the spar, and that's what the whole elevator is pivoting on. So, and like I said, that part there where it goes through the forward bulkhead here, if you look on the outside, there is where it's going through there. And obviously I've got the bulkhead hidden right now, but we're just looking at the spar. But that's where it crosses through. So again, that's a place where the pressurization needs to be maintained. And again, there'll be a bearing on the inside there that's a seal bearing with a pressure system there, so it won't allow the pressure to escape. So there's no bellows system in here like you have to have on most things. It's all going to be done with sort of seal bearings for where the controls cross over the pressurization system, or the pressure wall. And the same with, and I haven't done it yet, but for the throttle controls, those will just be using cables that'll go back through. There'll be a mount here that sort of corresponds to where the center console is, and those cables will come back down up under here, and they'll go back over the main tank that's behind the seats there, and they'll go right through the firewall, and those will be sealed, and you don't have to worry so much about the cables leaking because they're kind of sealed cable anyway. So that's kind of how the elevator and the aileron works, and I've explained how the steering works with the way it's sort of hydraulically set up. And again, these rudder pedal system here on that little slider there, that'll be electrically controlled, just like your sliding seats in your car. Just a little motor there with a gear drive to move that back and forth to get them right where you want them. So you'll have kind of an infinite adjustment there. It won't be like clicking into place. You'll be able to get it exactly how you want it to be, just with a little electric switch to adjust them. So it'll be kind of nice. So it pretty much covers everything with respect to the ailerons, the elevator, the rudder for steering, the brakes, and the anti-lock braking system, and the steering system here that I talked about, and also the drag brake system. Again, that's just going to be a button here on your control stick to activate the drag brakes. So I think that covers everything that I wanted to talk about in this video, and maybe I'll do another one for the next feature that I'm doing. But if you have any questions, feel free to email me, and I'll try and answer them for you. Thanks.